Imagine you are the captain of a cargo ship. The sea is calm, the engines are running, everything seems perfectly normal. Then you glance at the navigation screen. According to the GPS, your ship isn't in the ocean anymore. It's sitting on land near an airport, but the ship never left the water. So, how could the map say otherwise? This wasn't science fiction, it wasn't a movie. It was the result of a real technological problem that has affected ships and aircraft around the world. Somewhere, the navigation system had begun trusting a false signal, and that raises a disturbing question. If a map can be fooled, what else can? Every day, billions of people trust GPS. It guides our cars, tracks our deliveries, helps aircraft navigate, and leads ships safely across oceans. But almost nobody asks one simple question. How does GPS actually know where you are? The answer isn't just about location, it's about time. Thousands of kilometers above Earth, GPS satellites constantly broadcast tiny radio signals. Inside every satellite is an incredibly precise atomic clock. Those satellites don't simply tell your device where they are, they tell it exactly when each signal was sent. Your phone, a ship, or an aircraft calculates its position by measuring how long those signals take to arrive. It's an extraordinary system, but there's one weakness. By the time those signals reach Earth, they are incredibly faint. In some situations, a stronger fake signal can overpower the real one. The receiver doesn't know it's being deceived. It simply trusts the signal that appears most convincing. This is known as GPS spoofing. In documented maritime incidents, ships suddenly appeared in impossible locations on their navigation displays. While never leaving the sea, investigators found no engine failures, no navigation mistakes. The vessels remained exactly where they should have been. Only one thing had changed: their calculated position. The map wasn't describing reality anymore. It was describing the signal it had been given. Researchers later discovered something even more surprising. GPS isn't only a positioning system, it's also one of the world's most important timing systems. Those atomic clocks orbiting above us quietly help synchronize countless technologies: aircraft navigation, communication networks, parts of financial infrastructure, and many other systems that depend on extremely accurate timing. When those timing signals become unreliable, the effects can extend far beyond a wrong location on a map. That's why aviation authorities, maritime organizations, and cybersecurity experts treat GPS interference as a serious safety issue. Modern aircraft and ships are designed with backup systems and established procedures. But incidents involving GPS interference are a reminder of how much invisible technology our world quietly depends on. Most of us never think about GPS. We simply trust the blue dot on the screen. We trust that it knows where we are. But every map, every route, and every navigation system begins with invisible signals traveling silently through space. Most of the time, those signals tell the truth. Sometimes they don't. And when technology begins trusting the wrong signal, reality itself can appear to change. Perhaps the greatest lesson isn't that GPS can be fooled. It's that the modern world depends on countless invisible systems we rarely notice, until one of them stops telling the truth. Thank you for watching.